All right, so today we're going to be going through the Accounting 2302 Exam 2 review. So in this review, we're going to be reviewing topics from chapters 17, 18, and 19 from the 8th edition of our McGraw-Hill textbook that we use in class. So as we work through this review is significantly longer than your actual test. But if you look at the breakdown that I've posted, you'll see some of the topics that are on the test are absolutely on here. So we're going to go through several examples. We're going to talk about exactly how to go through things. I'm going to try to go through it fairly slowly. So hopefully it's pretty clear. And that way, if you need to go back, you can. But hopefully by the time you get to the test, you're moving along at about this pace or a little bit quicker than we're going to be going. And so you will be able to finish the test. If you do at all have any questions as we go through anything in this review, make sure you reach out to me as always. I'm either available in person during my office hours or online. You can get me through email or Zoom. And so I'll be happy to help you however I can. But make sure you are preparing for this exam. You do not want to drop the ball here. So here we go. First question that we have in this review, we're going to be looking at a problem asking us to compute plant-wide overhead rates. So in this problem, this is no different than stuff that we've done prior to this. The only difference is that in this case, they tell us, one, we have two products, and they tell us that we have our activity or our overhead items here in the middle. The only thing you have to be kind of careful with is in this case, you're using a single plant-wide overhead rate, which means we don't care so much about all of these expected activities as we care about the cost. So the first thing I want to do is come down, total up all of these overhead items, and I'll see that this comes out to be $2,180,000. So that's my first big step. Remember, whenever we're using a plant-wide overhead rate, our actual formula is going to be total estimated overhead divided by that total estimated cost driver. So in this case, what we were told is we said, okay, we've got our overhead, in this case, the $2,180,000. And they say, we're going to assume we assign this based on 125,000 budgeted direct labor hours. So the next thing we've got to do is come in here and we'll take our 2,180,000 that we just computed. We'll divide that by the 125,000 direct labor hours. And when I do that, that will come out to be $17.44 per direct labor hour. So that is my plant-wide overhead rate. So that's the first thing we had to do in this problem. Now, the next thing that we've got to do is actually come in and we have to actually assign, oops, let's go ahead and we'll clear out some of our drawings just to clean this up a little bit. And then we'll deal with the other stuff. So in this case, we'll just go ahead and type this in, the 2,180,000 divided by the 125,000 direct labor hours, just so it doesn't move around as we slide around on the screen. But there we have it. So there's our plant-wide overhead rate using direct labor hours as our base. Now, what we've got to do is the last step here is actually assign that overhead. So in this case, we'll notice that with the deluxe model, they told us the deluxe model required 2,500 direct labor hours. So we'll take 2,500 direct labor hours times, and then of course we have our rate, $17.44 per direct labor hour. That will cancel out the direct labor hours, leaving us with dollars. And in this case, we'll be left with $43,600. Now, on the other hand, we're going to come in and we're going to take, for the basic model, this one required 6,000 direct labor hours times still the $17.44 per direct labor hour. Of course, canceling out the direct labor hours, that will give us $104,640. Now, that's the end of this question. But let's talk about what this is actually doing and what it's telling me. So in this case, when I look at this, what I find is that my basic model is receiving much more of the cost on overhead than my deluxe model. And you say, well, that makes sense, Mr. Allen, because what we see here is that the basic model is using much more direct labor hours. So it makes sense that they would be receiving a lot more of the overhead cost. But I would ask you then, if you think that's the case, does it require the same amount of activity to produce a deluxe model go-kart as a basic go-kart, do you think? Or do you think there might be some costs that are only relevant to the deluxe model that right now might be getting shifted over to our basic model? And of course, that is the cost, or that is the issue at hand here, is that this single plant-wide overhead rate is very easy to use. You see that. It didn't take us very long. It just took a few steps and we're done. But the problem is there are some costs unique to the deluxe model right now that are temporarily being, or that are permanently, if you stay with this method, being assigned to that basic model. And the problem, of course, here is this can lead to some really poor pricing and sales decisions. It can lead to some bad decisions whenever it comes to possibly eliminating a product department or a section of your company, because if you have that cost assigned incorrectly, when you eliminate the product that was previously absorbing those costs are still going to keep coming in, but now you don't have a way to offset it. So you could actually hurt yourself here if you use this something like a single plant-wide overhead rate and you have a drastic difference in your cost allocation compared to something like activity-based costing, which of course is on this exam also. So we'll get to some problems where we look at activity-based costing in just a little bit, and we'll see why it does a better job. But for now, just be aware, hey, this problem with your plant-wide overhead rate is an issue, right? It is very easy, great, but it doesn't do a very accurate job of actually allocating these items. So very good. So there's the first question. Now, number two, we're looking here at ABC. So in this case, we are looking at some information from 17-8. So I believe that is the information that we have right here. So they say, go ahead, use ABC to compute the overhead cost per unit for each product line. Determine the total cost per unit for each product line if the direct labor and direct materials cost per unit are, and they give us that, 250 and then 180. If the market price for model 145 is 820 and the market price for model 212 is 480, determine the profit or loss per unit for each model. So in this case, we have Waycool, who produces two different models of air conditioners. The company produces the mechanical systems in its components department, and the mechanical systems are combined with the housing assembly and finishing department. In this case, we are told the activities, costs, and drivers associated with these two manufacturing processes and the production support process are below. So we see that here. We see our components department, we see our finishing department, we see our support department. And they tell us additional product information is here. So we see model 145 produced 1,500 units, model 212 produced 3,500. We see their welding hours, the batches, all that stuff. We see that very clearly here. Now what I'm going to do, I'm going to go ahead, I'm going to split this out into a window. And if you have me in class, you're very familiar with me doing this because I do it very frequently in class time, where we can keep our actual information on one side, and then we can actually see what we're doing on the other side. It just helps keep us a little bit more organized. Now, in this case, the hardest part of this question is actually the easiest. And you say, well, that doesn't make any sense, Mr. Allen. What does that mean? And what I mean here is, the most challenging part of this question, in my opinion, is just not making a silly typo at the beginning. Because what you'll find is that if you were to make some mistake here at the very beginning, or as you're getting these activity rates, then it's going to impact you all the way through the entire problem. So even though what we're about to do is not very difficult, as long as you know what to do, what you're going to find is that if you make a mistake here, it's going to dramatically impact your score on the exam, because you're going to continually get hit by losing points each time you use that wrong activity rate. So make sure you pay attention here in this next minute or so as we go through these activity rates, but especially when you're on the test, make sure you're careful. Common sense check the stuff you do in your calculator. If you put in 1,000 divided by 20, right, you should be getting 50. But if you don't get 50, right, or if you get, say, 500, hopefully you would realize, like, hey, I must have left off a 0 when I divided. Okay, and so hopefully you can common sense check things, at least for magnitude, like, am I roughly in the right ballpark? Even if you don't know exactly what the answer should be, make sure you're slowing down just enough that you can see exactly what you're doing. So here we go. In this case, we need to compute our allocation rates or our activity rates for each activity. So we start out here with changeover. So changeover has a $500,000 overhead cost assigned to it. So I'll go ahead, I'll take my pencil here, and I'll just show you where I'm getting that from. So this is the $500,000 that we're using here for changeover. So that's what that is. And then of course, in this case, that is allocated by the number of batches. So we have 800 total batches. So we'll divide that by 800 batches, and that will come out to be $625 per batch. $625 per batch. I'm just going to kick that way over to the side just so we can keep all of our totals nice and clean in one line. And it'll make it a little bit easier for us as we get down into the next part if we have our work really well organized. Now, for the machining department, we're just going to continue coming down. In this case, that's $279,000. divided by 6,000 machine hours. And when you do that, that comes out to $46.50 per machine hour. Now for setups, same thing. We're going to just continue coming down that cost line or that cost column, $225,000 divided by, and in this case, we are basing this on the number of setups. So $225,000 divided by 120 setups comes out to be $1,875 per setup. Now, in the finishing department, we come down, we've got $180,300 divided by our 3,000 welding hours. And when we do that, that will come out to $60.10 per welding hour. Now, with the inspection, we come down, we see here, this is $210,000 divided by, and in this case, we have 700 inspections. And when you do that division, this will come out to be $300 per inspection. Now, with the rework, we're going to continue down, just doing this exactly the same as we did before. So rework, $75,000 divided by the number of rework orders. And when you do that, this is $250 per rework order. Now, for the support department, we're going to come down. We have our purchasing. So this is $135,000 divided by 450 purchase orders. And when we do that, this will come out to be $300. Oops. Somehow my keyboard got messed up. 1 second, let's get this corrected. There we go. $300 per purchase order. Sorry about that, if that messed anybody up. Now, the next thing that we've got to deal with is this providing of space and utilities. Now, you've got to be a little bit careful here because I want you to notice something. As we look over here, you'll notice that they give me the space and utilities as two separate pieces, but look at the drivers. Their driver is the same. They're both allocating based on number of units. Now, the reason that is important is it means we have to be a little bit careful here. So let me ask you, would this be correct? If I came in and I said, okay, well, in this case, we've got our total cost here, which is $97,000. It's just the sum of the 32 and the 65. So if you want to pop that in a calculator, go ahead, but it's the 32,000 from space and the 65,000 from utilities. That gives me $97,000. Now, I'll be taking that and dividing by, and let me ask you if this is right. Since each one allocates on the basis of units, do I need to add those units like I added the dollars? In other words, do I divide this by 5,000 plus 5,000? Or do I just divide by 5,000? So this is the question a lot of students run into if you get something like this on the exam. And it seems like we have a really hard time answering this question. And like I said before, if you make a mistake in this top section, then it's going to really hurt you as you come down. So what we find is that in this case, you're allocating on the basis of the same driver. Those are the same units that we're talking about, which means you don't need to add the units. So you'll just be dividing in this case by the 5,000 units, not 10,000 units. Very, very common mistake that students will make. So be very careful as you work this through on the test, Now, you say, well, I don't know if I believe that, Mr. Allen. So can you prove that to me another way? And I say, well, sure, I can. So here's the thing. What we just got was $19.40 per unit. Now, if you don't believe that, and you say, well, I think we should have added that. Okay, well, had you added that, this is what you would have done. You would have done 32,000 plus 65,000 divided by 10. You would have gotten $9.70. Now, if we compute those as two separate pieces, because we could have done providing space first, then providing utilities, we would have done 32,000 divided by 5,000, and that's $6.40. And we would have done 65,000 divided by 5,000, and that's $13. Plus your 6.4 from before is the 1940 that we got here. So the point here is whenever you have drivers that are the same, they don't add to each other, right? It's the same thing. So if you don't want to combine the dollars and then leave the units alone, you don't have to. You could compute them separately. That's fine. But in this case, there was no reason to. So we just went ahead, we added those together, and we can go ahead and move on. So at this point, we've got the hardest part of this question done, which is just getting these activity rates. Because once we do this, Everything else is just a little bit of time that we've got to go through. So what we're going to do now is we're going to come down and we're going to look and we're going to say, all right, well, for the changeover activity, this is based on the number of batches. So what I'm going to do is come down, find my batches, and see how those are allocated. You'll notice in this case that whenever I look, I actually see that both models have the same number of batches. Because of that, I can do all of this on one line. So I'm just going to say here, 400 batches times $625 per batch. Now, this comes out to a total of $250,000 for each model. Notice in each case as we go down, they don't always, right, the two models being the two models do not always use the same amount of everything. So in some cases, we need two lines, but here we just needed one. Now, for my machining activity, this is based on the number of machine hours. So now I'll need to come down, find my machine hours, and I'll see that for model number 145, I have 1,800 machine hours times, and of course, I'm coming back and getting my rate from before, $46.50 per machine hour. And when I do that math, this is $83,700. Now, for model 212, this will be 4,200 machine hours times $46.50 per machine hour, which comes out to be $195,300. And we're going to repeat this process the whole way down. For setups, we'll grab our 60 setups because in each case, they both used 60 setups. And you'll see that if you look back over at the lower table on the left-hand side. And of course, our setups are allocated at $1,875 per setup. So for model 145, that is $112,500. And for model 212, that is also $112,500. So we'll go ahead, pop that in, and we'll continue down to welding. Now for welding, we'll see that we have 800 welding hours for model 145. Our welding rate was $60.10 per welding hour. And so when we do that math, this is $48,080. Now we'll come down, continue doing this for the other piece for model 212. This is 2,200 welding hours times $60.10 per welding hour. And that comes out to $132,220. $132,220. Okay. Now, for the next piece, we're going to keep coming down. We're going to now look at inspecting. For inspecting, we have 400 inspections for model 145. And of course, our rate per inspection is $300. So when we do that, this is $120,000. Next, 300 inspections times, and in this case, we see still the $300 per inspection. And this will come out to be $90,000. Now for the rework, we have 160 rework orders for model 145. And of course, we see that those cost us $250 per rework order. So $250 per rework order. When I do that, I believe that comes out to $40,000. Let me check that one real quick. 160 times 25. So there we go. Now for the next piece, we have for our rework, 140 rework orders times still the $250 per rework order. And when I do that, this will come out to be $35,000. For purchasing, 300 purchase orders times, and of course, each purchase order costs us $300. So $300 per purchase order. And when I do that, this is $90,000. Next, 150 purchase orders for model 212. Still times the $300 per purchase order. That will now come out to be $45,000. For space and utilities, this is 1,500 units times $19.40 per unit. And when you do that, this is $29,100 for model 145. And of course, 3,500 units times $19.40 per unit. That will come out to be $67,900 for model 212. Now, at this point, we are just about done with this problem, but I want to take just a moment to remind you of something. Now, in this case, the way this problem is set up, they're just asking me to calculate my overhead cost per unit. Now that's great. That is a fair question. It's a good question. Perhaps it's even the one you really care about in your life. But remember, there are some other costs that actually go into production. So let's just make a quick note here, just so we remind ourselves. So note, remember, in other words, to get average cost per unit, you must add total direct materials, total direct labor, and total overhead from activity-based costing to get your total manufacturing cost. So in other words, if this question had asked us, what is the average cost per unit, then all the stuff we just did is fine. But then we'd have to go back, and of course, they'd have to actually tell me how much we spent on direct materials, how much we spent on direct labor. They didn't give me the information here, so we can't even do that on this problem. But had they given me that information, I would need to pull both of those extra pieces in. That would then give me my total manufacturing cost. Then I could actually take that, and we'll say then take total manufacturing cost and divide by units to get average cost per unit. So not totally different, but just a little tweak, right? Don't forget, if you're asked for total average cost, right, or that average cost using all of your product pieces, then it's not just overhead you care about. In this case, that's all we care about. But on the test, you very well could get a question that asks you, hey, what's the average cost per unit? Well, in that case, you need all three pieces: total direct labor, total direct materials, and total overhead that you calculated here from activity-based costing. So whenever we come down my model 145 column and add all of that up, we'll come out to $773,380. And for model 212, this will come out to $927,920. Now, units produced. Well, model 145, we produced 1,500 units. And here we produced 3,500 units. Of course, that is still coming from that bottom table on the left-hand side. And when you actually do this division, you'll come out to a rate here of $515.59 in overhead for model 145 and $265.12 for model 212. So with that, we are officially done with this page. And we are ready now to move on to our next question. So at this point, I'm going to go ahead. I'm going to make this screen bigger again, and we're just going to continue on. Now, in this case, we've been asked to perform break-even analysis, but not just with any regular units like you might normally use. In this case, we are doing what is a more realistic situation, which is where we actually have what are called composite units. So here's the idea. Whenever you're dealing in real life, do you know of any company that sells exactly one product and only one product and is very successful? Okay, there might be some. I'm not going to say there are none, because there is always the exception. But by and large, most companies sell a mix of different units. They don't only sell one thing. They might sell 2 or 3 or 500 or 1,000 different products or more. And so what we find is that in real life, you actually need to do your break-even analysis with what we call composite units. And composite units work, as we're about to see in this problem, where you're going to have to figure out the ratio that you sell all of your pieces in. Then you're going to figure out a contribution margin per composite unit. And then at that point, it just works like normal. So let's go ahead and hop in and see how this goes. So in this case, now it looks like I forgot to actually delete this piece before I came up here, so that's okay. We'll just talk through it. So here we go. Remember, break-even analysis, at least in units, tells us that we take our fixed cost divided by our contribution margin per, and in this case, the big key here is per composite unit, per composite unit. So that's the thing we're looking for, right? So we're going to be told our fixed cost, and if you actually come up into the reading, you'll see that we are actually given that. It's given to us right here. Annual fixed costs shared by all three products are $250,000. So we have that. So that's where that came from. And you're saying, well, that's great, but where does this 122 come from? Because as I read through there, I'm not seeing that. So let's see if we can find it. So before we get into any actual computation that we're going to be doing, I'm just going to go ahead and read through what we've got. So Patriot Company manufactures and sells 3 products. So that's probably going to be important. We have red, white, and blue. Their unit selling prices are red sells for 20, white for 35, and blue for 65. The per unit variable cost to manufacture and sell the products, red is 12, white is 22, and blue is 50. Their sales mix is reflected in a ratio of 5 to 4 to 2. So for every time we sell a unit that consists of 11 individual pieces, 5 of those are red, 4 of those are white, and 2 of those are blue. Annual fixed costs shared by all 3 products are $250. One type of raw material has been used to manufacture all 3 products. The company has developed a new material of equal quality for less cost. The new material would reduce variable cost per unit as follows: red by 6, white by 12, and blue by 10. However, the new material requires new equipment, which will increase annual fixed costs by $50,000. So here we go. Part 1 says, well, all right, if the company continues to actually use the old material, determine our break-even point in both sales units and sales dollars of each individual product, So here we go. In this case, what we've got to remember is that we have 5 units of red, we have 4 units of white, and we have 2 units of blue. So that's our first step. In this case, we're going to come down and we're going to see, well, each one of these units sells at $20 per unit. And here for our cost, we have a cost on the red of $12 per unit. So we're going to go ahead and do this out. So 20 times 5 is $100. And 5 times 12 is $60. So now we're going to come down, we're going to do the same thing for white. So for white, we were told back in the reading that white sells at a price of $35, and then it has a variable cost of $22. So here we go, at $35 per unit. And here we've got at, in this case, $22 per unit. 35 times 4, well, that is $140. So we'll just drop that in. And of course, 22 times 4 is $88. Now, for the blue, it's going to work in much the same way. We were told here blue sells at a price of $65 per unit. And we were told that our cost on blue is $50 per unit. 65 times 2 is 130, and 50 times 2 is 100. Now, at this point, we're ready to go. All we need to do is add straight down. So my unit sales price per composite unit is just the sum of all of those. So 100 plus 140 is 240, plus 130 is 370. And then in this case, 60 plus 88 is 148, plus 100 is $248. So we now have our 2 pieces. We have our selling price of a composite unit, 370, our variable cost, 248. At this point, we can calculate our contribution margin per composite unit by taking my sales price of 370 minus my variable cost per composite unit of 248, and this will come out to $122. Now, what we need to do next is take my contribution margin ratio. So that will be my contribution margin per composite unit, which we just calculated as the 122, and we'll simply divide by the $370. When we do that, this will come out to a ratio of 32.97%. 32.97%. Okay, so that's what we end up with. So at this point, go ahead, take just a second, look it over, make sure you understand what we just did. And now we're going to go ahead and move on. So for the next piece, they ask us to go ahead and compute break even in individual product unit sales. So at this point, all we have to do is actually come in and figure out that we have our unit sales of red at break even. So in this case, we have 2,050 composite units times, and then of course, for each composite unit, that sells 5 pieces of red. So it's going to be 10,250 units. Here, for the unit sales of white, this will be 2,050 composite units times 4. And that will come out to be 8,200 units. And here we have 2,050 composite units still times, and then of course, we sell 2 units of blue each time. So that's going to be 4,100 units. Now, the third piece here is go ahead and compute break even in individual product dollar sales. Well, at this point, that's not too bad. because we've got the units. So for for red, we know we sell 10,250 units, and we know that we sell each unit at a price of $20. So when I do that, this comes out to $205,000. Now, for white, we're going to come in, we're going to take our 8,200 units, multiply this by our $35 per unit, comes out to $287,000. And finally, we're going to deal with blue. So blue, we had 4,100 units times, and it sold at $65 per unit. And this comes out to $266,500. Now, at this point, we are going to have a bit of a rounding difference, but not too bad. Now, there is another way to do this, and this is to come down and actually use our break-even in dollar sales formula. So in that case, this would be $250,000 divided by our contribution margin ratio, which was 32.97%. So we'll divide by 0.3297. Now, when you do that, this will come out to be $758,265. Now, if you actually add up these three numbers right here, 1, 2, 3, what you'll actually find is that those come out to be $758,500. And it's because we, of course, had some rounding along the way in some of our computations. And so what we find is that this should work. It's just off a little bit because we ended up having to round that contribution margin ratio. But in any case, there we have it. Now, at this point, we're ready to go ahead and move on to the next piece. I know there was another part to this question asking us about part 2. That is not what I want to focus on for the purpose of this review. If you do have a question about how to do part 2, certainly come talk to me. I'll go through it with you. But for the purpose of the review, I really want us focusing here in on part number 1. Okay. Now, this video is already going to be long enough. I want to try to keep it as concise as possible. So in this next question, we have our cost behavior estimation using what is known as the high-low method. Now remember in class, we talked about several different methods, or in the chapter, if you read, you'll know that there were several different methods. The high-low method is one of the methods that we use to determine cost estimation or cost equations. So what we're going to do here is we're going to identify my high point and my low point. And in this case, it actually happens that those are consecutive months in November and December. And we know that we base this decision of high or low based on activity level, not based on cost, In a lot of cases, your high month will be the month where you had the most production and also the most cost, right? And in a lot of cases, those two things work out nicely. And in some cases, your lowest cost month is also the month that you produce the lowest amount of units. That does happen, but you want to be careful because sometimes you might have a higher cost month where you actually produce less than another month, and then you would end up grabbing the wrong point. So the way we make this determination is we base our decision of high and low on our activity, on our number of units produced. So in this case, you'll notice that as you come down, well, our units produced highest point was here at 240, and our lowest point was here in December at 60. Once again, those are not always consecutive months, certainly. In this case, they happen to be. Now, the first thing we've got to do is we've got to figure out our variable cost on a per unit basis, because one of the underlying assumptions here with this method is that the only reason all of these months do not cost the exact same, and you'll see that, right? These costs are all different. The only reason that happens, according to this method, is because we changed the number of units that we produced. If we'd always produced, say, 90 units, we should have always gotten that amount of cost, for example. And so what we find is that what we do is we start with our high point, and we take our 8,100 minus our low point, 3,600, and we'll divide that by, in this case, 240 units from the high point, and we'll subtract out the 60 units from the low point. So what we do, in other words, we figure out essentially the slope of the line. You'll recognize this from algebra as exactly that. You'll notice on your y-axis, you've got your dollars. Here you've got your units. And so what we have, for example, in November, well, we produced 240 units and we had a cost of 8,100. So if we make this about 8,100, so 81. Then here in our low month, we produced 60 units. And what we ended up here with was a cost of $3,600. And essentially, we're just trying to connect that as a straight line. Of course, since this is your variable cost, that should hit down at 0. But this is the idea. This is the idea. So what we're trying to do is if we're just, well, truthfully, if we were just graphing the variable cost, that should hit at 0. In this case, we're actually graphing a mixed cost because it's the total cost. So truthfully, that will hit somewhere other than 0 because you will have actually a fixed cost piece. So I'll try to correct that in the picture a little bit. Doesn't have to be perfect, but you're looking at something like this where you do have some amount of fixed cost, and then you, of course, have your slope of the line. What that's going to let us see is that if you remember from algebra, we said essentially the slope of a line was equal to y is equal to mx plus b. So in this case, our m, the slope, this will be my variable cost. This intercept, that b, this distance here, this is actually my fixed cost. This is actually my fixed cost. Okay, so now that we've got this all labeled, and do you have to draw the graph? Of course not. But if you've never seen it, sometimes it's nice to see. So at this point, we can go ahead, figure out what's going on here. 8,100 minus 3,600, well, that comes out to be 4,500 divided by 180. It comes out to be $25 per unit. Now, what you're going to have to do on your test is test both the high point and the low point. So I've done that here for us. I've set it up so that we can do that. So using the low point, what we end up with is this. Well, my low point, if you recall, your total cost equation is that total cost is equal to two things: total fixed cost plus total variable cost. Total fixed cost plus total variable cost. So in this case, using the low point, our total cost was $3,600. And that is equal to, in this case, my total fixed cost plus my total variable cost. Now, what we just got was $25, but notice that's $25 per unit. So we'll need to multiply that by our 60 units that we actually produced. When you do that, you'll see that your 25 times your 60, you can replace that with 1,500. So you end up with 3,600 is equal to total fixed cost plus 1,500. You'll subtract out the 1,500. And when you do that, you'll find your total fixed cost is $2,100. So there's your first piece. Now, at this point, you could be done, right? If you were confident in this, you would be done, except that on the test, I believe I do have you justify it both ways. But what that means is that if you're confident in the math you just did, you know that when you finish this, you should also come out to 2,100, because that underlying assumption tells us, hey, what we end up with is this situation where the only reason our costs are different is because we have a change in activity level, or a change in production level. So if we know that, then we know that we should end up back in the same point. So let's see if we do. So using the high point, in this case, we have a total cost of 8,100. That's going to equal your total fixed cost plus $25 per unit times, and in this case, you have 240 units. So in that case, 25 times 240, you can replace that with 6,000. And when you do that, you'll subtract over the 6,000. And of course, you will end up getting that your total fixed cost is $2,100 once again. And so it does work, and you can check it. So this is a very nice question on your exam because you can check it before you move on. If you got a fixed cost number that was different in either case, you would actually have a situation where you know you've made a mistake. Now, the test doesn't ask you to do this, but I probably will if you take me for cost accounting. So I'm going to ask you for the actual total cost equation. So in this case, you just need the total cost equation. That is going to be equal to, and truthfully, it's not going to be too bad because all we're doing is we're setting this up in the form of a line. So this will be 25x plus 2,100. 25x plus 2,100, where of course, x is just your level of production. So if you want to go back and test that, feel free. But what you'll find is that you're doing the exact same thing. 25 times 60, oh, that's 1,500 plus 2,100. That gets me back to the 36. So this is essentially the goal, because once you have this, oops, thought I had my box icon. Once you have this figured out, you can now quickly estimate production cost at any level. So now if I said, well, estimate total production at a cost of 200 units. Okay, well, great. I just do 25 times 200 plus 2,100, done. Estimate total cost at 135 units. Okay, great. 25 times 135 plus 2,100. And so it gives you this very easy way to actually start making predictions. Now, for the next piece, we're going to go ahead. We're going to move on down to our next problem, which is going to be dealing once again with sales mix and break even. So before we do that, I'm going to go ahead, clear everything out, and continue on. So here, once again, we've got this idea of composite units. So US Mobile manufactures and sells only 2 products, tablet computers and smartphones, in the ratio of 5:3. So in other words, in each basket of goods that we sell 8 products, and those 8 products, in this case, we have what was first, tablet computers. So we have 5 tablets. So we've got 1, 2, 3, 4, 5 tablets, and we've got 3 smartphones. So in each basket of goods that we sell, this is what we're selling: 5 tablets, 3 smartphones. Now, fixed costs are 105,000, and the contribution margin per composite unit is 125. What number of each type of product will be sold at break-even point? Okay. So in this case, the first thing we got to do then is figure out how many total composite units we have, or that we need to sell. So we're going to take our $105,000, which is our fixed cost, divide that by our contribution margin per composite unit. And when you do that, you'll find you need 840 composite units. Now, the number of products sold at break even in total is going to be my 840 composite units times 5 plus 3, or times 8, which is 6,720 products. Now, that's not the end of the question, though. The question actually asked me, but how many of each type of product are we actually selling? So what we need to do now is take that 840 times 5 for my tablets, which comes out to be 4,200 tablets. And we'll do the same thing for the smartphones. Our 840 composite units times, but in this case, only 3 smartphones, which comes out to be 2,520 tablets, or sorry, phones. 2,520 phones, 4,200 tablets. Now, you say, well, that's great, but why did we even do this step? We didn't need to. There's no real value gained from doing this. Why not just go straight to here? And here's why. What if you accidentally punched in 4 here? Well, if you accidentally punched in 4 there, you would actually end up getting 3,360. And if you did this double check with the 5 plus 3, then you'd see that my total should be 6,720. And when I pop that in my calculator, 3,360 plus 2,520, I don't come back to 6,720. The reason I want you to do that extra calculation is it gives you a check figure. You say, okay, could I make a typo on the calculator once? Yes. Is it likely I'm going to make identical typos multiple times in a row? Is much less likely. It could still happen, certainly, but it's much less likely. And so whenever you do that, you then go back and you see, oh, okay, I don't tie down. I must have a typo somewhere, and it would let you catch that error before you turn in your test. That's why I want you to go ahead and take the extra, what it take, 5 seconds maybe, to punch that in, get us a check figure, and then don't forget to actually use it. Because a lot of times students will do this. They'll do this check figure step, but then they'll still get something that doesn't tie down to their check figure. And because they didn't actually use it as they should have, which was to come in here and add these two together and make sure it comes back, then the check figure is a complete waste of time. But if you use it, it can really help you prevent you from making a few mistakes on the test. So we don't want that to happen. So use the check figure. It won't take you much longer, but it will potentially save you several points on the test. Okay. Now, into chapter 19. So the first thing we've got here is a question that only asks me to compute unit and inventory costs under absorption costing. So here we go. Trio Company reports the following information for the current year, which is their first year of operations. Now, compute the product cost per unit using absorption costing. Compute the product cost per unit using absorption costing. So what that means is I'm going to have to figure out what costs actually affect product cost per unit under absorption costing. So there are a couple that we know for sure. Things like direct materials, of course, direct labor, of course, and variable overhead, of course. But what about fixed overhead? Does fixed overhead influence product cost under absorption costing? What do you think? So remember, we're comparing two methods here in chapter 19. We're comparing variable costing, which we first saw in chapter 18 in class, or as you read through the book. And then, of course, in this chapter, we're tacking on absorption costing. So what we need to realize is that under absorption costing, we do include fixed overhead as a product cost. So fixed overhead will be included, $160,000 in this case, divided by 20,000 units. Because in this case, they want everything on a per unit basis. That'll come out to $8. Everything else is given to us 15 plus 16, and then 4, and then of course the 8. So 15, 16, 4, and then the 8. Okay. At this point, we can go ahead, total that up. Comes out to $43. Determine the cost of ending finished goods inventory. Well, you just figured out the cost per unit. So we've got our total product cost per unit. Well, that's 43. That's what we just did. And if we come back up, we'll notice that they actually tell me the ending finished goods inventory is 6,000 units. So I'm going to come down. I'm going to multiply that by 6,000 units. And if you want to title this, this is just the number of units and ending inventory. And when you do that multiplication, 43 times 6,000, you will come out to $258,000. Okay, at this point, we're going to go ahead and clear out our drawings so they quit bouncing around the screen. Next, we're going to deal with our cost of goods sold. So in this case, we're going to take, once again, our total product cost per unit, $43. And we're going to multiply that by the number of units that are actually sold. Remember, for something to be a cost of goods sold, it must actually have been sold. So if we look back at our table, we'll once again see that the number of units sold, 14,000. 14,000 units times $43 per unit. We'll go ahead and correct that, just so our actual units do tie down and cancel like they should. So $43 per unit times 14,000 units will be $602,000. $602,000. And we have finished exercise 19-1. Exercise 19-1 is now complete. And we can go ahead and move on to our next exercise, which is actually going to have us preparing an income statement under both absorption costing and variable costing. Now, this problem is actually fairly nice in that this problem deals with the information, but it deals with it in a way that is more user-friendly. And you'll see why, I think, pretty quickly if you remember the big differences between absorption and variable costing. So as we just peruse the data that we've been given, why is this one going to be easier than the one we're going to work after this one, which is a much more challenging version of this question? So what's the difference? Well, in this case, notice this last line here, units produced and sold, meaning what? We produced and sold the same number of units, which means that my total absorption costing income will be equal to my variable costing income. And that is a huge relief if I'm looking at this on the exam, because what that tells me is I can check my work. I can check my work. Because if I get to the end and I go, wait a minute, something's not right here because I get different levels of income, then I know I've made a mistake. So this is really, really helpful because it means that I can easily check my work. You can also check your work the other way. Whenever your units produced do not equal your units sold, and we've certainly seen that in class, and we'll go through it some more. But what you'll find is that the biggest issue is whenever we're looking at this, when the units produced do not equal units sold, those income numbers are different. But in this case, we know they will be the same, and that will make our lives much, much easier. So in this case, we have Ray Company. We're going to start with the absorption costing income statement because that's what they asked us to prepare first. So in this case, they tell us we sell a single product at a price of $216 per unit. Data for the single product first year of operations is below. So we know we sell this at $216 per unit, and we sell 20,000 units. $216 per unit times 20,000 units. That's $4,320,000. Now, this is absorption costing, which means we do have cost of goods sold on this income statement. But in this case, the way I'm given the information, I'm going to have to do some work to actually compute cost of goods sold. In this case, and I believe if you get this question on your exam, the way it wants you to do this is to actually format it exactly as we're formatting it here. So make sure you pay very close attention to how this is set up in case you were to get this question on your test. So less direct materials, less direct labor, less our variable overhead costs, and of course our fixed overhead costs. So here we go. For our direct materials, if we look back up, you'll see that we are told our direct materials cost us $20 per unit. And of course, we sold 20,000 units. So 20 times 20,000, well, that is $400,000. For direct labor, we look back up, this is $28 per unit times, in this case, 20,000 units, which is a total here of $560,000. For our variable overhead costs, this is going to be, look back up, $6 per unit times 20,000 units comes out to $120,000. And then our fixed overhead costs they gave us in total as $160,000. This will allow us to compute our cost of goods sold by adding up those four numbers in this middle column will come out to $1,240,000. Now, what do we get when we subtract sales and cost of goods sold? Well, of course, this is equal to gross margin. So 4,320,000 minus 1,240,000 is $3,080,000. $3,080,000. Okay. Now, at this point, we've got a few things left that we need to deal with. Talking primarily about our selling, general, and administrative expenses. So in this case, we have a couple of things. We have our fixed piece, which was $200,000. And we have our variable piece. And you'll notice that we are told the variable piece here is $18 per unit times, of course, our 20,000 units. This is a total of $360,000. Next, we'll have our total selling, general, and administrative expenses. And when we do that, this will be $560,000. Now, at the end, we have net income. And remember, if we had a loss, that would be denoted in parentheses. So I'm going to go ahead and use that notation. But in this case, of course, our gross margin is $3 million. Our total selling, general, and admin is less than $600,000. Of course, we will have income, $2,520,000. But had we had a loss, this is the way we would have notated it, is with parentheses around the number. Now, in this case, of course, we don't have a loss, so we're not going to use those parentheses, but do be familiar with the notation. It is certainly possible on the exam you could end up with a loss situation. Now, in this case, we're not dealing with income taxes. That's not the point of this question. So we're going to ignore that for the purpose of this question. But what that tells me now that I've done this is because my units produced are equal to my units sold, whenever I actually do my variable costing income statement, I know that I should come down to net income of $2,520,000 before I even begin. And that is really nice peace of mind if you recognize, or if on the test you do get a question, where you actually have units produced equal to units sold. So here we go. Next, absorption costing and variable costing income statements. So we did absorption. Now we're going to do variable. Well, the good news is it's still an income statement. So it still starts with sales. And in this case, that's $216 per unit times our 20,000 units. Did we write that down on the last one? Yes, we did. Okay, good. For some reason, I could not remember writing that. I wanted to go back and correct it if I didn't. So this is 4,320,000. And you'll notice exactly the same as under our absorption costing because it's sales. That's not what's changing between these two methods. What's changing is how we look at the costs. So in this case, there we go. We've got the first piece done. Now, less. And you would think, oh, this is cost of goods sold because that's what you did in 2301. And that's what we just did on the last one. But be careful because this is the variable costing version. Under the variable costing income statement, you will not see cost of goods sold on it anywhere. Instead, this says less variable costs. Now, what that means, and I want you to be careful, it doesn't say less variable product costs. It says less variable costs, which means all variable costs. So here we go. Direct materials is certainly one of those. We'll deal with the math on that in a second. Then, of course, we have direct labor. We'll deal with the math on it in just a moment. Next, we have our variable overhead costs. Of course, that has a little bit of math for it. And whenever we get to our variable selling and admin, we'll see that in just a second also. But here we go. Now, truthfully, all of these calculations we did just a minute ago. I'm just going to rewrite them for peace of mind so you have it all complete on one page as you're looking at your notes later or as you're reviewing this handout. But on the test, if I were doing this, right, if I were a student, there's no way I would rewrite this because you've already done the math for these pieces. You're just grabbing the numbers and reformatting them. So here we go. For direct materials, this will still be $20 per unit times 20,000 units. And this will be $400,000. For direct labor, in this case, that's $28 per unit times 20,000 units. That is $560,000. For my variable overhead cost, this is, I believe, $6 per unit times 20,000 units. And that is $120,000. And for my variable selling and administrative expenses, what we end up with here is the $18 per unit times 20,000 units. When we do that, this is $360,000. So we'll get rid of this extra space back here. And when we do that, this will give me the ability to calculate my total variable costs. The way we'll do this, of course, is by adding up all of these numbers in this middle column. And when I do that, this is $1,440,000, giving us, in this case, contribution margin of $2,880,000. Now, at this point, we've dealt with the variable costs, but of course, we remember that total cost is equal to total fixed cost plus total variable cost. So we now need to deal with the fixed piece, so less our fixed expenses. And in this case, we have two fixed expenses. We have fixed selling and administrative. And if you look back, that's $200,000. And here we have fixed overhead costs. That is $160,000. This comes out to be $360,000. And at this point, this will be my total fixed expenses. And of course, we'll come down to net income or loss. If this had been negative, it would have been denoted, of course, in parentheses, $2,520,000. And we're fairly confident we've done this correctly because we said that in this case, we should have found that our net incomes were the same. And of course, we did. So I'm just going to go ahead. We're going to look at these two side by side. So let's see here. There's our absorption. And we'll get our variable next. And here's our variable income statement. So looking at these side by side, hopefully you can notice there are a few distinctions, but not too many. So look at what stays the same. You still have your sales. That's the same. And if you actually pair these things up, you'll notice that a lot of the numbers didn't change. And of course, they don't change whenever your units produced equal units sold. So look, direct materials, 400, direct materials, 400, direct labor, 560, direct labor, still 560, variable overhead, 120, variable overhead, still 120, fixed overhead, 160, fixed overhead, 160, fixed selling general and admin, 200, still 200. And of course, your variable selling and admin, 360, and still 360. So it's the same information, it's just being formatted differently. So don't let yourself get too worked up or too confused about, I've got to learn two totally different things. No, you don't. No, you don't. You've got to learn a few formats, but the content is extremely similar. So notice a few key terminology differences. I want to point these out. When you're on the absorption costing income statement, the first thing you're subtracting is cost of goods sold. When you're on the variable costing income statement, you subtract out variable costs. That makes sense. Link up the word variable here with variable here. That's fine. Now, what that means is that everything variable goes here. But notice here, this is just the product costs. This is just the product costs. Now, here, once you do that first level of subtraction on the absorption costing income statement, you get cost of goods sold and you get gross margin, right? So once you actually do the subtraction, you get gross margin. Once you add all these things up, you actually do get cost of goods sold. On the variable costing income statement, when you add up all your variable costs, you don't get cost of goods sold, you instead get total variable cost. And you remember that sales minus total variable cost, that is contribution margin. Contribution margin. So that is exactly what we get. So as long as you familiarize yourself with a few of these terminology related differences, the distinction between absorption and variable is not super difficult, but it does require that you recognize those key things. If you let yourself get confused, or if you think cost of goods sold is on both, or if you have anything like that happen, then it can lead to problems. It can lead to problems. So do be careful there. Do be careful there. All right. Next, for our next problem, we're going to look at another situation of absorption and variable costing. But I want you to notice something. This one going to be a little bit harder than the last. Why? This section right here keys me in that I've got a very challenging problem ahead of me. Because what I notice here is, well, units produced are less than units sold. Units produced are less than units sold. So if that's the case, and it is in this case, so here we have units produced less than units sold. So we've got to prepare, notice first the variable costing, then the absorption costing. So I changed the order on me. That's okay. It doesn't have to be that I always prepare one first then the other. I can prepare them in any order, but do be aware. Now, in this case, I see that units produced are less than units sold. So units produced are less than units sold. So that has a relationship with net income. And what that relationship is it tells me that my absorption income should be less than my variable income. My absorption income will be less than my variable income. And here's how I remember this. All right, this is the only way I can keep it straight myself, is I say always think. I'm trying to find a good spot to put this where it won't block too much. But always put this in terms of absorption income to variable income. Because here's the thing. In this case, what you're doing is you're taking that sign and it's staying in the same direction. So units produced less than units sold, absorption income will be less than variable income. If units produced were greater than units sold, then absorption income should be greater than variable income. So if you start trying to say, like, when units produced is less than units sold, variable income is greater than absorption, that is certainly true. But you are much more likely to start getting your signs flipped around and getting very confused. Always keep absorption first. Units produced less than sold, absorption less than variable. That's the way I want you to remember it. That's the best way to prevent yourself from getting confused come exam day. Now, at this point, we're going to go ahead. We're going to start working through this. So Gonna clear this out, and then we'll check at the end and see if our assumption was right. So here we go. This one formatted just a little bit differently, in how your book wants you to set this one up. So I'll take you through step by step on this one, just like we did the last one. But in this case, we're going to go ahead, we're going to split this so we can, of course, see what we actually need as we are working down. So here we go. Starting, of course, with our sales, still starting with sales, even though this is a variable costing income statement, still start with sales. Well, in this case, we see that each unit sells at a price of $320 per unit. And in this case, how many units did we sell? So 115, is that right? So times 115,000 units. No, that's not going to be it, right? That's the amount we produced. So be careful here. Students will accidentally grab that number on occasion, but in this case, we did produce 115. We sold 118. So 118,000 times $320 is $37,760,000. Now, at this point, we want to take out our variable expenses. So very similar to what we did before. The only difference is now what we're going to end up with is this situation where we're going to do a lot of this computation down here in this bottom section. So here we go. In this case, what we want to start with is our beginning variable finished goods, So we'll start with that, beginning variable finished goods. And they gave me that as $405,000. So that's given to us right here in our table, $405,000. Now, to that, we will need to add our variable cost of goods manufactured. So that'll be things like direct materials. Well, we were told that our direct materials, so let's come back and look over here. So our direct materials in this case will be the $4,600,000. So that's going to be $40 per unit times the number of units we actually produced. So $40 per unit times 115,000 units. That's going to be $4,600,000. Next, we're going to follow that up with our direct labor. This was given as $62 per unit, still times the number of units we actually produced, 115,000 to $7,130,000. Next, we've got our variable overhead. So our variable overhead was given to us $3,220,000. This will give us what is called our total variable costs available. So whenever we do that, we're going to come in. That will be, of course, the sum of all of our information that we've got here. And that will, of course, include this $405,000. At $405,000. So if we do that, just go ahead and show that out. So 405,000 plus 4,600,000 plus 7,130 plus 3,220, $15,355,000. And now I realize I did that on my 10 key at my desk and not on the calculator on the computer. So if you want to check that, feel free. I'm not going to go through it again, but I just checked it on my 10 key. So that is correct. $15,355,000. Now, at this point, you would normally have to subtract out your ending finished goods. But in this case, we have something nice happening here. Notice that we started the year with 3,000 units. Then we produced 115,000 units. Then we sold 118,000 units. So we've actually got 0 units in ending inventory. And because of that, this works out really, really nicely. If I give you a question that is this difficult on your exam, it will end up with 0 units in finished goods. So you don't have to worry about that here, right? For a cost exam, I'd probably have some ending finished goods here and you'd have to deal with that extra step. But for a principles exam, I don't think it's necessary. So in this case, this will give us our variable product cost of goods sold. That will just be the $15,355,000. $15,355,000. And at this point, we're going to go ahead. We're going to come down for our next line up top. This will be our variable product costs. And it will be that $15,355,000. Now, we're still under variable costing, so we'll still need our variable selling and admin expenses. And if we look over, that is $1,416,000. That gives us a total here of $16,771,000. That'll be our total variable expenses. Now, at this point, this will allow us to compute contribution margin, which is of course the difference between the sales of 37 million and the total variable expenses of 16 million. That's $20,989,000. And now we've got our fixed expenses category. So we've dealt with variable, we now need to deal with fixed. So in this case, we have our fixed manufacturing costs. So our fixed manufacturing costs, that's $7,400,000, and that's our fixed overhead piece. Then we've got our fixed selling and admin costs. And whenever we do this, this will be, of course, our $4,600,000 found right at the very bottom of table 2. That will give us a total here of $12 million in total fixed expenses. And that will give us net income in this case of $8,989,000. $8,989,000. Okay. So that's what we end up with here. That's what we end up with here. All righty. Now, moving on to our next piece, we're going to deal with our absorption costing income statement. So similar, but slightly different in format. So we're going to go ahead. I'm just going to copy this very first line just so I don't have to retype it because it's exactly the same. So there we go, 37,760,000. But remember, on the absorption costing income statement, I'm starting here with cost of goods sold. So we're going to need a few things. We're going to need our beginning of finished goods inventory. Our beginning finished goods, well, that's given to us here as this $645,000. So we'll go ahead and we'll pull that in. Next, we'll need to add to that our cost of goods manufactured. So to do that, we're going to have to come down and we're going to need to actually compute that. So here we go. In this case, we're going to start with our direct materials. So once again, that's 40 times the 115,000 units that we produced. This is 4,600,000. In this case, our direct labor, still $62 per unit times the 115,000 units. That will come out to be 7,130,000, just as it was before. Next, we've got our variable overhead. Our variable overhead, in this case, 3,220,000 is given. And of course, our last piece here is our fixed overhead. So our fixed overhead, in this case, given $7,400,000. That will allow us to compute our total manufacturing costs. Now, when we add all of this up, this is $22,350,000. Now, that is what we're going to pull back up top right there. So I'm going to go ahead and highlight this just in the same yellow color, just so it's easy for you to make that visual link. All right, we took the information we got from here and we plopped it right there, right into our main computation or into our main calculation. Now, at this point, we've got our total goods available for sale. That's $22,995,000. Now, I'll be honest, a lot of the formatting here, I don't really agree with, but this is how your book has it set up. So we're going to keep it the way your book does it. But truthfully, all of this computation would never happen on the face of an income statement. Same thing true with what we did a second ago with the variable costing here. You would not be doing any of this computation here. You'd be doing all of this in the notes to the financials and referencing things back. But for whatever reason, this is the way your book wants it formatted. So we're going to keep it that way. So there's the $22,995,000. Now, what we need to do now is we need to subtract out our ending finished goods. And as we saw earlier, this is nothing. Because what we found was, well, there were no units left. We started with 3,000. We produced 115. That's 118,000 total units. We sold 118, so there's nothing left. So there's no cost here that we need to back out. So this will give us cost of goods sold equal to the 22,995,000. This allows us to come down. We get gross margin. Our gross margin then, $14,765,000. Now we need to back out our selling and administrative expenses. And to do this, we're going to need some extra room down here. So in this case, what we're going to do, we're going to just take the 1,416,000 plus 4,600,000, and that is going to be $6,016,000. So this 6,016,000, I'm just going to highlight some color. Let's see here. We'll do green, that's fine. So $6,016,000, and that's just coming back to right there. Okay, at this point, you're ready to go. You got your net income, and your net income is just going to be that difference, $8,749,000. $8,749,000. Okay. Now, what we said before we began was that we expected our variable costing income to be greater than our absorption costing income. Well, absorption is 8,749,000 and variable was 8,989,000. So we were correct. Our intuition was right. But the question now is why? Why is it right? Like what's going on here? So in this case, the dollar difference in variable costing income and absorption costing income is the 3,000 unit difference between what we produced and what we sold. So the 3,000 unit difference right here between the 115 and the 118, and $80 in fixed overhead per unit. $80 in fixed overhead per unit. So at this point, you might then be asking, well, what do we see here? Like, why is it, one second, is it still sharing? Okay. Looks like it's sharing. Hopefully it's been sharing this whole time, or that's going to be a disaster. All right. In any case, you might be asking yourself, well, where was this 240 before? Like, why is it that that's the case? So if you look back, you'll notice that we have this oddly convenient $240,000 sitting right here. And of course, that's where this is coming from. Remember, under absorption costing, what's happening here is whenever we ramp up production in one period, so if I increase production, that allows me to actually store. I'm going to switch over to the keyboard. This is going to be a lot of writing and it's going to look terrible if I write it with my mouse. So this allows us to actually store costs on the balance sheet as an asset instead of expensing them right away. So this is the fundamental distinction between absorption and variable costing, is that under absorption costing, I can make income essentially whatever I want it to be by simply increasing production levels. So I need more income, great, I'll increase production. What's that going to do? It's going to drive down my fixed overhead cost on a per unit basis. That'll then allow me to take that lower cost on a per unit basis, shoving that over when I sell units to the income statement and cost of goods sold, reducing the expense recognized and increasing income. And in the meantime, that's going to take more of that cost, put it on the balance sheet as an asset and inventory, and actually increase my assets. So all around, it looks pretty good. Of course, the problem here is if you do this too much, what you're going to end up with is a situation where you have all of your current assets tied up in inventory, and it's not going to be a very effective way to run your company. Now, you could do that. It is an option to dramatically increase your inventory, dramatically decrease your inventory, depending on what you're trying to do. But any savvy investor or any savvy person that you're trying to get a loan from is going to see what you're doing very, very quickly anyway, because it's going to start to affect things like your quick ratio. It's going to start to affect things like inventory turnover, days sales and inventory. All those ratios are going to start looking really, really, really bad if you start just amplifying your inventory to try to boost your income. So not a great strategy, but it is something you want to watch out for. It is something you want to watch out for. Okay, with that, we're ready to go ahead and continue on. Whoops. Okay, so we're going to go ahead, make this big again, and we're going to finish out our packet with some smaller questions compared to the last few that we just did, which were very, very large. Of the last two that we did, I would say the first one, where the units produced equals units sold, is much more similar to what you might get on a test situation. But I wanted to at least walk you through that one big example for sure, where you can see what happens when units produced do not equal units sold. I think that is a great thing to look at, because in practice, it's almost never the case that units produced equals units sold. But in a principles course on an exam, I'm likely to give you a situation where that is the case. And then maybe in cost, I would be more inclined to give you the one where you actually have units produced different than units sold, if that makes sense. So in that next class, that 300 level class or that 3000 level class, you would probably get that harder question. Whereas in a principles course, I would likely keep it at that lower level where you have just the situation where you can actually check yourself very easily. Oh, okay, my units produced equals units sold, so my income under both methods should be the same number. Just a little bit easier for you to work with. All right, in this case, under absorption costing, company had the following per unit cost when we produce 10,000 units. Compute the company's total product cost per unit if 12,500 units had instead been produced. So in this case, we have our direct materials, we have our direct labor, we have our variable overhead, and we have our fixed overhead. So these are all the costs that we need. We have our total product cost per unit. So here we go. Our direct materials, still $3. Our direct labor, still $2. Our variable overhead, still $4. None of that changed. But our fixed overhead, is it still $5? So it was 5 before. Is it still 5? Well, let's think. Before, we were spreading that $50,000 in fixed overhead out over 10,000 units. But that's not the case anymore. In this case, they're saying, oh, we actually produced 12,500 units. So this is actually now spreading that cost out over more units. Therefore, less cost is being assigned to each individual unit. This will come down to give you a total product cost per unit of $13. $13. So very good. So there's this one. Okay. Now that's the first part. Second part, if production is greater than sales, cost of goods sold under absorption will decrease, And that's what we're looking for here. So if production is greater than sales, so in other words, if we produce 12,500 units, but we only sell 10,000, well, now my total product cost per unit is only $13. So now my cost of goods sold would equal $13 per unit times the 10,000 units, which would be $130,000 versus previously it would have been $140,000. You say, well, where's that extra $10,000 going, or that difference? Well, that difference is now sitting in inventory on the balance sheet because you took that piece of that actual fixed overhead and you now stored it over on the balance sheet as an asset. Okay, over on the balance sheet as an asset. So this is what we see, and that is what would end up happening. Is you'd actually have a cost of goods sold figure here of $130,000. So it would just be the 13 times the 10 that were actually sold. And then that remaining piece that would have been there normally will now be on the balance sheet as an asset in inventory. So very interesting problem to look at. Probably too simple for an exam, but still a really, really good question for you to look at just conceptually. Okay. Now, I like this problem a lot because it makes you actually come in and justify what is happening here with this overproduction. So I believe this is the second to last question in our packet. So we do have this one and one more, and then we'll be done. So here we go. In this case, Jackie Inc. reports the following annual cost data for its single product. So we see that. If Jackie increases production to 80 while sales remain at 60, by how much would the company's gross margin increase or decrease under absorption costing? Assume we have sufficient idle capacity so that we could double production. So in other words, 80,000 is within the relevant range. We can do this. Okay, so first thing we got to look at are a couple of things. We need to look at our direct materials cost per unit, our direct labor cost per unit, our variable overhead per unit, and of course, our fixed overhead per unit. So at the 60,000 unit level, my direct materials, direct labor, and variable overhead are $9, $6.50, and $11 respectively. And what's nice here is that all of that stays the same even at the 80,000 production level. What's going to change here is my fixed overhead. Right now at 60,000 units, this is computed as the 720,000 divided by the 60, which is $12 per unit. Here, I'll be taking that 720 dividing by 80,000, and that's $9 per unit. Now, at this point, this will come out to $38.50 in cost of goods sold at this level, and $35.50 at the higher production level. If we still sell 60,000 units in both cases, then what we end up with here is $2,310,000 in cost of goods sold at 60,000 units. And we'll end up at $2,130,000 right here with the 80,000 units. Now, they almost look like the same number, but they're not, right? There is actually a difference here. So if we come down and we prepare our sales through gross margin, our income statement through gross margin, so sales less cost of goods sold will give us gross margin. So in both cases, our sales number, $3,360,000. So in this case, that is, let's see, where do we get that? Normal production sales level, 60,000 times the 56. So this will be the $56 per unit times the 60,000 units. I couldn't remember if this problem just gives you the number if you had to actually multiply it out, but there we go. So 60,000 times 56, that is 3,360,000. And of course, that's the same at the other production level also, at the 80,000 unit level. Now, our cost of goods sold here, well, this is going to be $2,310,000. And here, this will be $2,130,000. This allows us to see that we end up with gross margin, in this case, of $1,050,000. And here we end up with gross margin of $1,230,000. Okay, next. If Jackie increases the production to 80 while sales remain at 60, how much does the gross margin increase or decrease? Of course, assuming this. So it's essentially the same question. We're just putting it down into table format. So what we find is that the gross margin will, and in this case, actually increase. So if you want to highlight that one, you can do that. If you want to delete decreases, do that. If you want to circle increase, that's fine. Whatever you want to do. But make sure you understand that we're saying gross margin will actually increase by, and it will be $180,000. It's this difference right here. And you say, well, why is that? Well, that's because we had a number of units that were actually sold, in this case of 60,000 units. And each one of those now had $3. Oops, must have accidentally turned off number lock for a second. Each one of those actually had $3 less in fixed overhead assigned to it. That means that the change in cost of goods sold is $180,000, and that is, of course, going to be equivalent to the change in gross margin. So there we go. Now, at this point, we're ready to go ahead. Moving into our very last question of this review. I know you have to be excited, but here we go. Let's go ahead and tackle this last one, and then we'll be completely ready for our test. We'll walk in on exam day and knock that thing out of the park. So here we go. Empire Plaza Hotel is a hotel with 400 rooms. Its regular room rate is $300 per night per room. The hotel's cost is $165 per night per room and consists of the following. The hotel manager receives an offer to hold the Junior States of America convention at the hotel in February, which is the hotel's low season with an occupancy rate of less than 45%. JSA would reserve 100 rooms for 4 nights if the hotel could offer a 50% discount or a rate of $150 per night. The hotel manager is initially inclined to reject the offer because the cost per room per night is $165. Should the offer from JSA be accepted or rejected, what is the contribution margin from accepting the offer? So here's the thing. You will come across situations like this in real life when you get out of college very frequently if you're running anything, if you're accepting clients. And so what you end up with is a situation where we're not that busy right now. We've got empty rooms. Are we better off taking this even though it appears at first glance our total cost per night per room of $165 would be greater than what they're willing to pay at $150. So The manager in this case, at first glance, is making a pretty good decision. They're like, hey, I don't think this makes sense. I'm not inclined to do this. So let's not, right? That's the essential position at the beginning. But let's see if that's a well-informed decision. So let's compare what's actually happening here. If we accept this, we'll get $150 per night in revenue. We'll rent 100 rooms for 4 nights. And then everything will cancel except dollars, and we'll be left with revenue of $60,000. You say, well, that's great. $60,000 in revenue, of course, accept this. But maybe not, right? Maybe there's something else going on here. So we now need to look at our variable costs. Well, our variable costs, we look at our cost structure, we see that's only $40 per night times 100 rooms times 4 nights, and that is $16,000. This gives us an increase in contribution margin of $44,000. So should we accept the offer? Well, in light of this, we say, yes, accept the offer. Why? What's happening here? Why does it make sense to accept this, even though the rate per room that we're actually receiving of $150 is less than the total cost per room per night? Well, those fixed costs, they're incurred whether we rent the room or not. And what do we know about contribution margin? Well, contribution margin actually goes to help cover fixed cost. So by getting a situation where contribution margin is greater than 0, we decide we absolutely should accept the offer. If we'd come down and we'd seen contribution margin was something like this, negative 10,000, then I would say, no, don't accept the offer. You're worse off doing so. But that's not what happened here. In this case, we are actually better off by $44,000 accepting this special offer. Now, here's the thing. This is a little bit more involved in real life. This is a little bit more involved in the sense that there are some other things you want to consider. So here we go. As long as, so this is true. Yes, accept the decision as long as there are no additional fixed costs. This could be something like additional staff must be hired to handle the extra demand. There are certainly others, so I'll just say here, for instance. And as long as no customers who would otherwise pay the full price of $300 per night are turned away, the hotel will realize an increase, or a $44,000 increase in contribution margin. This is the idea. If they accept this offer, they will actually increase their contribution margin by $44,000, and that is a good thing. This manager should accept this offer as long as these caveats are met, right? If, for example, you had a customer who was turned away that would have normally paid $300, that of course doesn't mean not to do this, but it does mean it starts to whittle away at this incremental contribution margin. So if you had, say, 10 customers who were turned away that would have normally paid the $300, then your contribution margin from this is only $41,000 because you have to back out that $3,000. So in real life, a few other things you'd want to consider, but in here, the answer is yes, accept the new job. You do for sure have a question like this on your exam. Make sure you understand this one. Not a super difficult one. I put it there, hopefully right at the end to try to give you a pretty easy one after you get through with one of these absorption versus variable cost problems. So that'll kind of zap you, I'd imagine. So I tried to give you something a little bit nicer right on the end of the test. And so hopefully you finish that out nice and strong. So if y'all have any questions, once again, please, please, please never hesitate to contact me. Always feel free to come by my office. I'm happy to walk you through anything you want. But otherwise, good luck studying and good luck on this test. Thank you so much.